I'm going to try and make this work. All right, hi. My name is Mike-Fiedler. I work at a company called Datadog. We're a hosted monitoring as a service platform, but I don't really want to delve too deep into that. I want to talk about some good ideas and practices around instrumenting your application in an environment where servers go up and down all the time. You'll have to forgive me. They say you come to Vegas, you lose your money. I lost my voice. So if it sounds raspy and scratchy, it's because I lost it somewhere last night. If you find it, I need it. I've been doing these kind of things for probably about 15, 20 years now, dealing with stuff. And if any of you have been doing this for any amount of time, you know that there's kind of a history of how we look at things and how we've looked at what is good in systems and operations and administration. We've looked at how long a server has been up, how long we've had all of these application stacks that they do one thing, and then you've built like 40 different servers, and they all do this one thing, and they do it really well. And then, you know, that's one stack. And in those big intertwined clusters, we unwittingly introduce single points of failure. Whether you like it or not, it happens, right? Somebody decides, okay, I need this particular job to be batch processed every night at 2 a.m., and they set that job to run on one box and one box only. And then that box goes away. So we've been doing this for years, and we all kind of, I mean, hopefully you know that these are the ugly warts of what we're doing, but you know, we can do it better. What we do today and what we want to focus on for today and the future is a lot of service-oriented architecture, where you're designing pieces of your infrastructure to speak to other pieces of your infrastructure. You want services to talk to other services to produce an overall larger meta service, something that provides business value for your customers. And we're in this game now where if you are not able to scale on demand, somebody else who's doing something similar to what you are doing is going to be able to do it faster than you, and you're not scaling as fast as you need to be, and they're going to go elsewhere and lose your business. And we've also gotten to the point of the whole big data revolution where we have all of this user behavior data, we have service behavior data. We can get all of these things as data points to make decisions about what should we do next, right? Google are famous for this, for doing A/B testings on color. They'll add they'll change a color in one widget somewhere. And they'll do it for, I don't know, 5%, 10% of millions, and just a staggering amount of users. And then they'll take that data and make a decision of, are people clicking this widget more or less than before? So we've gotten to the point where we can make these decisions based on the data. And everybody wants to see that your service can stay up for as long as it needs to, and you have to be transparent about all of it. So if you're not watching it, your customers are, and they're going to tell you something's wrong before you know. And that's the worst feeling ever, when you get that email, you get that phone call saying, hey, your site is down. If you can't immediately say, oh yeah, we know, we're working on it, thank you, then that customer is going to lose a lot of faith in your service. In our modern day, this is kind of like an idea around what a simple service application stack may look like. Right? You have your users, they come through a load balancer or some sort of distribution model to get to your web application tier. And when I say web, it doesn't have to be a browser, it could be a service, an endpoint, an API, really doesn't matter. It's just kind of a HTTP transport, right? And again, don't hold me to these. Everybody uses protocols differently, but the ideas are the same. And then that API or that web service or that web page is all going to retrieve some data. Because data is what people are after. Whether it be a WordPress site going for content in a database, whether it be a social media site which is hosted behind a series of load balancers, web application tiers, and a bunch of different kinds of data stores. But if we design for a particular pattern, and these patterns emerge all the time, and if we can adopt in our infrastructures and our ideas some of these patterns, we can realize that, yes, failure is inevitable. Things will fail. That it's just going to happen, right? Just like that one batch process, if you have one database server, if you're running one web server that does one component of your architecture and everything else is like multiple replicated and everything is great, but that one single point of failure is going to cause you to experience some outage at some point, because failure, it happens. This is why we have servers that have dual power supplies. This is why we have hard drives and RAID configurations. Everything fails, right? There's like odds. They'll bet you on it downstairs on when your server is going to fail. It's going to happen. It's just a matter of time. So knowing that that is going to happen and starting from that starting point of, yes, this is going to fail. It's always going to fail. It's just a matter of time. You can start to design to tolerate failure. Because if you try and say, I'm going to design this component, I'm going to give it 8 power supplies, I'm going to give it 40, hot plug CPUs, the one thing that you can't predict is that the whole data center goes up in flames, right? So now that one server that you've banked the everything on is gone. So if you figured out that the component that you care about is one server, then have that in another server. If you care about a data center, have another data center. But design your application stack to handle this failure. Whether that means, looking at data storage solutions that auto-replicate, whether that is using a service that their commitment is to doing that, but then try and fault-tolerant your service. Maybe you don't use just one provider of a critical service. Have a backup plan. So that way, even if you are using this one service or one component, you know how to move from that component to another one. So some of the terminology that we use in the modern in the modern world are building businesses, building services that aren't just one thing. They're kind of an aggregation or a collection of ideas, whether that be, I'm going to be an application developer only that rides on top of somebody else's tier of an operating system. Whether that be, I'm going to do a web service that relies on the fact that people actually have web browsers that support what I'm trying to do. And all of these components, you can leverage existing services. You can leverage pretty much every other idea out there is done. You don't have to do it all on your own. And a lot of the stuff out there is pretty good, right? I don't want to have to recompile a kernel for every single server, for every single service. I can leverage pre-built ones that are good enough. And if they're good enough, I can offload that. It's like outsourcing, really. I'm not going to do the things that I don't need to do. I'm going to focus on the pieces that I want to do. I'm going to solve the problems that my business is trying to solve and build the services that I want to produce value from. And every single piece of the technology stack, whether it be the hardware, the hypervisors and virtualization world, whether they be third-party APIs, they all produce metrics in one fashion or another. It's not always the same format of metrics. It's not always easy to bring them all together, but they all produce numbers on consumption, temperature, usage, how long this thing's been running, And all of these numbers are critical to building the picture of what's going on. And the thing that we found is that if you don't measure, you don't know. You're flying blind, and at some point you're going to hit a wall. And you'll be scratching your head saying, why did we hit a wall? If you didn't measure it, you don't know why you hit that wall. So it's critical to think about every single component that you care about and measure that. If it's measuring latency to load the entire page, then track that. If it's latency to make a call between the web page and the database, track that too. Because now, if you see one latency go up and you scratch your head and you're like, I don't know why my users are taking now 3 seconds to load a page they used to load in 1 second. If you're not measuring the components that are behind that one web page, you're not going to see where the slowdown is. And obviously, we want to monitor all the things. We want to have this insight into every layer. It's hard. It is really hard. You could stop what you're doing today, focus completely on monitoring for probably the next 5 years, and still not be done. Right? It's hard, but you have to start somewhere. And some of the easiest places out there, like yes, I build a tool that helps do monitoring, but there are so many open source ones, and there's a ton of other ideas out there that can help you monitor. There are services that'll do that. If you're not doing something, you're going to lose to the guy who is doing something, who's keeping an eye on the service, who cares about the page slowdown at 3 a.m. It only happens at 3 a.m., and I only have 3 users logged in. Well, guess what? Those 3 users are not coming back next time. And that's 3 users, that's 5 users, that's 100 users, that's tens of thousands. It builds up. And we want to do this. We want to monitor all these things. And it's really important to take a moment to compare different sets of monitoring things. Right now, if you're using Amazon and you're using EC2 instances, CloudWatch will produce a metric that shows you how much CPU utilization that instance has right now. You know, this is percent idle versus percent consumed, and I'm comparing 2 different nodes here. That's why one goes up, one goes down. But at least now I'm looking at one metric. Am I looking at what is causing this? Well, not yet, but at least this is like the overarching broad idea of, you know, something may be wrong when this drops to 0. Something may be wrong when it spikes and stays at 100 forever. However, if you're only looking at a CPU metric from a hypervisor, you're not going to get the full picture. Again, because you're only looking at one dimension that's showing you only a particular piece of the puzzle. Over here, I'm showing you a graph from Datadog where we're running an agent on the same set of machines. And yes, does it look similar? It does. But there's a lot more variance in the dips and valleys. Why is that? Because I'm producing metrics at an interval of 10 seconds as opposed to 1 minute or 5 minutes. So I'm capturing a lot more resolution, a lot faster, and it rarely actually hits 0. It rarely goes all the way down. It rarely stays all the way up. But that previous one is going to show me a little different. So by looking at both of them, I can see, well, kind of like this is a smoothing algorithm that's happening over time, right? Do I care about if something is pegged for 5 minutes? Or do I care about it was pegged for 30 seconds or less, and I actually need to investigate something? And that's just one metric, and there are thousands of metrics that we can go into. But this helps me, as an operator, take a look at what kind of instances I'm running. The reason I'm showing a blue and a purple one here, I actually compare 2 different instance types for the same workload. So over here, that kind of paints a 20% variance in performance, right? And over here, it looks a little different, right? That blue line is a lot more spiky. But that purple line, the newer box, I decided on a more CPU, faster CPU instance type, it seems a little more stable. It seems that the numbers aren't dropping all the way down. And this helps me when I'm doing kind of an evaluation on instance types. I now have insight into what is really going on from the CPU perspective. That's only one stat, and typically not the stat that the executive team really cares about. They want to know how fast that user's page is loading, right? So I set out and I said, I'm going to build a stack. I'm going to build a demo stack to produce an idea. And I used a lot of open source tools. I used HAProxy. It's an open source load balancer. It's pretty fast. Apache HTTP server, pretty much industry standard, unless you like Nginx. In that case, that's also industry standard. Bottle.py is a Python micro web framework. It's very similar to Flask. I didn't want to build a whole full-featured like Rails or Django app. It's a really simple app that counts words. Mongo was a really good data store for this because Mongo will tolerate failure. It'll auto-replicate across multiple instances in a replica set. And if one dies, another one will take over. So that was a key element that I made a choice in. Like, yes, you could use RDS if you're using structural data. You could use Dynamo. You can use a wide variety. I wanted to use Mongo because I was having fun with Mongo that day. And obviously, it's all built on top of EC2. The other aspects of tolerating failure and being able to spin up more instances was using Chef or any infrastructure automation framework, right? You can use CloudFormation, you can use Puppet, you can use Chef, you can use Salt, Ansible. There are so many out there that it's pretty much pick the one you like. You don't have to buy anybody else's Kool-Aid. You can choose the ones you want to choose, the ones that make sense to you. But if you're not doing it, if you're not choosing something, you're going to lose to the guy who has made a good choice, who has built up that body of ability to spin up 10, 50, 60 new instances on demand. Hell, auto-scaling groups is another type of configuration management because you have that pre-baked AMI, I don't know. And you can scale that up on demand. It's pre-configured. And obviously, I use Datadog to monitor the entire stack because that was fun. And in order to do any kind of web application demonstration, I built a system of random users that would pretty much scale up slowly and just slam my web tier with random words. It's a word counter. So the first thing I wanted to look at while I'm looking at the operations of my site is how many words are being inserted into the database per second. And as you can see, there's kind of a steady rate when I was ramping up, just testing this with a few users. And then I stopped the test. And then I ramp up again. And then I even hit a peak. So even with using a standard rate of users, database operations can do things that you don't expect. It's not a standard rate. When you hit some threshold, you may get longer timeouts. You may get more users bursting in than you expected. Even if you have 500 users a day, and you've had 500 users every single day for the past 2 years, that one time that somebody tweets a link to your site that gets retweeted by another person, that's put on Slashdot and Hacker News, and has an article written about this one tweet that guy put a link in, your site is now under a barrage that you were not expecting before. And then I move up the stack and I say, okay, well, now that I had that huge peak in database operations and I was inserting more, did I have a huge influx of requests at the Apache layer, at the web application container, I guess is the appropriate term for it? Did I have more requests coming in at that given moment? And it doesn't look like it. It looks like everything's pretty straightforward. You know, if I do kind of a, whoop, that's backwards. There we go. So at that moment, yeah, I get some more inserts, but there's not a whole lot more. I mean, it looks like there's even a dip in the amount that Apache is taking in at that moment. So is one user inserting more words than normal? Now, obviously, this is a random application. These are random users. These are simulations against models that kind of can be anything. So if I haven't instrumented my application, I don't know how many user inserts are happening per second or per request. All I know is that Mongo got unhappy and Apache was fine. So I'm kind of looking at two sides of the story, but I'm missing that crucial element in the middle. Even I go higher up the stack. I want to see, all right, was there a dip? Was there a spike? Were there latencies in my HA proxy load balancing? Was I not doing the right algorithm? Do I have sticky sessions enabled and something got messed up there? I didn't have sticky sessions enabled. So it was kind of these are requests, bytes going in and out, right? Am I writing more? Am I reading more? Everything looked uniform. So why did it happen? So I have all these instances, and they all do certain things. And when I scale up and down, and when I add more instances, I could call them host names. I could call them, web server 1, web server 2, and so on and so forth. And anybody who's done any kind of server naming scheme, it falls apart after a little while. All you need is to have like web server 3 disappear, and now you have a gap in your numbering system. Right? So now if you've had some sort of like loop script that goes to every web server and install something, you have to like exception handle number 3 because it's gone now. I mean, you could replace number 3, but is that really fair? Number 3 was there, but it's gone now. It should never be replaced. So what we use and promote using is metadata about an instance, about a server, to describe the services that the server or instance provide. So I don't really care what the name is. Amazon is very, very helpful in giving me a pretty unique random ID, which is like, I have lists of these, and they're not helpful. What's helpful are the tags, the instance metadata, the what availability or region this instance is. So that way I can then look and say, all right, show me all the web servers in availability zone A, and show me their performance versus availability zone B. Because maybe there is something wrong with my load balancing algorithm or something along those lines. By using instance metadata, I group servers together as services, and I don't care about an individual server. So I can use all of these as query dimensions to look at data. So here's a graph of system memory available on any given host. And this cluster that I'm looking at is a MongoDB cluster. That's my 3-node replica set. And at some point, right past 7, my replica set failed. One node disappeared. It happened to be the master node. I'll tell you the secret. I destroyed it. It didn't just disappear. And I wanted to measure my application's performance and what the behavior would be like when the master node goes away. So not only did the database just fail over and everything keep working, but the auto-scaling group populating this spun up a 3rd replica set member, ran the chef code to provision it to join the replica set, and the monitoring system I'm using picked that up on the metadata tag of a Mongo replica set member, and automatically shows me that the memory it starts consuming just pretty much even with the previous one. So now that I've instrumented it and I've built it all together, it all kind of works, and now I get to see all those components, but I'm still not seeing my application behavior. I've seen the database, I've seen the instance, I've seen memory consumption, Apache, load balancer, all of those really important pieces of my application, not the application itself. If you haven't heard of StatsD and haven't checked it out, you should. StatsD is a non-blocking UDP asynchronous protocol that was developed by the guys over at Etsy, really smart people, and has been forked, updated, rewritten in every pretty much modern day language, even older languages. Like, people take this protocol, it's a very simple, straightforward protocol to communicate metrics data about anything. It follows a very straightforward format. You can inspect the packets over netcat. You can just look at the data. It's very straight. It's like pipe delimited, and like, this is the metric name, and this is the value, and this is the host it came from. Done, right? And that's all you need. And the idea behind this is that if you are instrumenting your application and the thing that your application is reporting to goes away or is slow, I don't want my application to be slow. I don't want the JavaScript embedded in my page to hang when it's trying to post data back to somebody else's API. I want to be able to see all of the data, and if there's any problem with the monitoring of my system, I don't want that to affect my system. Using statsd, I can put in my code messages to request that every single time my web application receives a word or a message, it increments a counter, a statsd counter. Just increment that counter and say, I've handled a message, I've seen a word. And then by shipping those stats out of your application to a centralized monitoring service, you can use Graphite, you can use Collecti, you can use all these things. I use Datadog because it works, and it works for me. Oh yeah, and I work there. But the spikes that we can see are pretty consistent. Like up until I kind of ramp up the test, my application is sustaining around the 20,000 words per second with very, very minimal instances. Like I'm using M1 smalls and mediums because why not? Let's push this thing to its limits. And I can see that as I ramp up the amount of users, there's an initial huge spike. It doesn't kind of like climb slowly. There's a spike, and then even further on, I see there's a bigger spike, right? And that spike over at pretty much 7 o'clock, that happened pretty much in conjunction with my database failure. But I'm only seeing this because I've instrumented my application to report these metrics. And now I'm comparing a couple different instance types of messages handled per second. So as I develop my application, and I say, OK, I want to increase the application tier or the web tier to a different instance type, to better CPUs, to more memory, to whatever the resource constraints that my application has, I can do a very straightforward A/B comparison by taking one instance type with a metadata tag of web server, another instance type of metadata per web server, have my application that's already instrumented because I did it already. I did it once, so why would I not continue to do that? Have it instrumented to report the metrics of how many messages it's handling per second, and then do a straightforward comparison. Because I can see that when I start the new one, right, the purple one, it's not doing anything. I have not included it into my load balancer pool. But I can see that I'm still sustaining about 20,000 messages per second. All right, everything's going well. Now I want to do a real workload comparison, so I flip one off and flip the other one on. And I can see that just apples to apples, but it's really apples to oranges, that I'm able to sustain now 25,000, what is that? 5,000 more messages per second on average. It pretty much never dips below the previous one's behavior. It's constantly higher. So now I've derived insight and said, you know what? I'm probably going to choose this new instance type. Then I turn the other one back on because I want to have both in C. OK, now they're both handling 15,000 messages per second. So I have 30,000, but why am I not processing 30,000 on the previous one? Just doing this A/B testing exposed to me that about 10,000 requests per second are being lost because the previous instance type was unable to sustain that load. But I wasn't triggering an error. I wasn't throwing an exception. I wasn't doing any of that. I was just dropping that message on the floor. So now people using my site to count their words, I don't know why they would use that, but they're using that to count words. And those messages are being lost. So that tells me that I have a scalability issue. But I'm looking at all of these metrics and trying to see, how do I want to scale this? What should I be scaling? So later on, I actually did introduce an exception handler, but I didn't show you that here. This is literally what my application looks like. This is code up on GitHub. You can find it. Bottle, you import this in Python. You import PyMongo to speak to Mongo. You import JSON to parse JSON. I create a connection to the database, and then anytime a word comes in at the REST path of insert this word, I insert it to the database, and I increment a counter. Right? That's all I want to do. I want to see how many times this word has come in my database. Why? Maybe I'm doing a Twitter feed analysis of hashtags. You know, this model could map to pretty much any big data problem, but I was using it to count words, and I wanted to see kind of the most popular words in a random situation over the course of time. So here I have the data is going into my database. It's happening. It's being pushed into my database. And instrumenting this code was 2 lines. There is absolutely no excuse for me to not do this everywhere. I imported the library, and I incremented a counter. That's it. Now I get those graphs of how many words per second I have. It's 2 lines to get started. It's a whole lot more lines to keep going. It's so much fun. Because now you get to see all those different method calls, all those different requests. You could theoretically instrument every single method call in whatever language you're using of your application tier and do a measurement of, well, here's the amount of requests that happened in Apache, and here's the aggregate total of metrics that I've collected for every request across every web server. Am I missing something? Maybe I didn't instrument it, or maybe messages are being lost between Apache and my code. If you're not measuring it, you don't know. And that's what it looks like. When I start ramping up and I've got about 600 messages per second, I turn on the valves of, all right, I've got the /dot effect, everything's working, and now it ramps up to 1,400 words per second. I now know exactly how many words are being inserted into my database per second. And I can react to this number a lot more accurately than I can to a database counter. I can react to this better than an HA proxy counter, because this is what my business value is. My business is counting words. If I need to count more words, and I need to grow my application tier, I now know that I'm getting more words. If I see a steady increase and then a dip, then that's going to tell me another part of my infrastructure is wrong. You know, maybe I've hit a capacity limit. But it gives me that insight of now I know what the next thing I should look at is. Instead of 3 a.m., my phone exploded, and now I don't know what to do. Like, yep, service is down. Okay. We've all been there. That's no fun. But having something to look at that will guide you to the next thing that you want to look at and fix is so crucial. And here's where I put all of those together. So I don't want to just look at one graph at one time. I want to see all of them together. I want to see how many sessions I have in my load balancer and what my current limit is. I have 2,000 available. Am I getting near that? If I'm getting near that, then I need to add more load balancers, sure. How many words am I inserting? That was the previous one. And how many Mongo inserts? Like, that's an interesting, different kind of curve compared to the count of words inserts, right? Is there something on a memory threshold, or am I blocking on disk writes? It's a different curve, and it tells a different story, but that's a story that only is a piece of the entire whole. And you have to see the whole in order to get the different pieces of the narrative. And that lower right-hand one, that's the database connections, and the colors change because the purple host went away, and a blue host took it over. There's a lighter shade of blue on top of that. Those are replica set connections, but those are predominantly master connections to a database. So I see that there's a huge spike when the purple one fails because Every process is trying to get a connection to a master of the database, and then it kind of settles back to where it was supposed to be. So this actually tells me a really good story. It tells me everything is working the way it should and the way I want it to work. Not unexpectedly. Yes, I had an unexpected database failure, but my service still works. Everything keeps chugging along. And that's the business value that we keep trying to build as services and as APIs and ideas. Not, I want the best database that's going to stay up forever. It's going to fail. It's just a matter of time. Don't be caught unaware. I hope I'm not telling you something monumentally and fundamentally surprising. You probably heard a lot of these ideas before. I hope I put a new angle on it so you can see. But if you are caught unaware, it's the worst feeling in the world. We're talking about it. We talk about dynamic scaling. We talk about monitoring because it's important. And being caught with your pants down is the worst, right? You get the executive tier banging down your door, breathing down your neck, and they want to know, why did this happen? How did this happen? How did we not have 5 contingency plans already? To a certain degree, they're right. I mean, the common response is because we didn't have the time, the money, but the executive tier didn't know that. They didn't know that there were no contingency plans. Otherwise, they wouldn't be asking you. They'd be like, well, we screwed up. And they don't want to do that, right? So by having all the planning and all the ideas in place, even if your idea is at 3 a.m., if this happens, because everything happens at 3 a.m., by the way. It's not 2:30, it happens at 3. Boom. If it happens at 3, what do you do next? Do you call someone? Do you restart a service? If you don't have a reaction pattern, if you don't have kind of a playbook or what to do, then you will be caught unaware. If your data center goes up in flames, what do you do? If that means you call up your CEO at 3 a.m. and you say, hey, our data center is gone, we need to tell our customers, then that's something. It's not, well, I don't know what we're doing now. At Datadog, we monitor everything. We monitor the implication of every single request. And here, I'm doing a metric alert on a dynamically scaling group. I want to know if my Apache CPU performance, so Apache reports on CPU performance in its stats, as well as your server on CPU. So you can kind of see how much CPU is Apache using versus how much CPU is available. So I want to know, not if the system CPU has gone to hell, but if the CPU that Apache, the service running on top of it, and it produces this metric, I should be watching that. It would be irresponsible of me not to watch it. And I say, you know what? Show me these web servers, and then alert on any given web server if it goes above a CPU load of 5 on average. I chose that number in conjunction with my instance type and the load performance. These numbers are you got to see where that works out for you, right? These are not, this is the end-all number. No. But you got to figure out what your thresholds are and set a threshold alert. And then I tell whoever's on call, whoever, it may not be me, I wrote the service and handed it off to another department. But I give them some knowledge about what to do when this alert fires. So I show that when this thing explodes, here's the next thing you should look at 3 a.m. Because we've all gotten that email, PagerDuty, whatever you have to alert you, and it doesn't give you enough context. It says something bad happened. And you're like, cool story, bro. Something bad happened. All right, now what? I didn't write that service. I've never heard of that until today. So by giving the information to the people who need it when they need it, we are giving them contextually specific, dynamically changing information. I have not set up this metric for my 5 web hosts. I've set it up for any web server tagged with the metadata of web server. I don't care about what those host names are, but I care about how many I have and that they all keep working the way I expected them to.